Team Mew, the science crew. Team Mew, the science crew. Mew, 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 Mew. Team Mew, the science crew.
Bio 360.
Team Mew, the science crew. Mew, 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 Mew. Mew, 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 Mew. Team Mew, the science crew. Here's the crew.
Happy to see you. So for today's episode, we will be talking about the big HT, hypothesis testing. So a statistical hypothesis is a claim about the population parameters, see? And this claim may or may not be true, but that is where the hypothesis test comes in. Come on, let's see. Oh, my old friendly hypothesis test. C. It is used to determine whether there's enough statistical evidence in order to support our claim. You see, we humans are natural skeptics. So, to test whether things have worked or not, we kind of assume that they haven't. This is what we call the null hypothesis, where a claim is the same as the theoretical expectation here. We also have something called the alternative hypothesis, where a claim is actually different. So you see, both the null and the alternative hypotheses can be expressed in either population proportion, mean, median, or the difference between two means. So the variable actually dictates our assumptions and conditions, as well as a test statistic that we use later on. You know what? Let's look at an example. Let's go.
Consider the following.
Statistics students believe that the class average is 65%, while the professor thinks that the class average is actually higher than 65%. So the professor randomly samples 30 students of the 120 students to test the claim. Here, we assume that all the assumptions and conditions are met. This right here is an example of a one-sample t-test, as there's only one measurement variable, which is our theoretical expectation of what the mean should be. So here, our null hypothesis is the mean is equal to 0.65, while our alternative hypothesis is that the mean is greater than 0.65, as the professor thinks it's greater than 65%. So you see, the purpose of the hypothesis test is to determine the p-value. The p-value is actually the probability of getting the observed results if the null hypothesis is true. But you see, we use the p-value to determine if the effect that shows up in the sample indicates that there's an effect in the population, or if this effect is likely due to chance. This is quantified by the significance level, or alpha.
What's that?
See, alpha is a value for which if p is less than, it's considered statistically significant. Most biological research actually uses an alpha of 0.05. There's nothing special about the number, okay? It's just what's been agreed upon. So if the p-value is below alpha, then we conclude that it is unlikely that this null hypothesis is true. So you know what we do with it? Reject it. So you see, if the p-value is actually higher than alpha, that's when we fail to reject the null hypothesis, as there is enough information to say that it's not true.
Please consider the following.
Back to our scenario. The professor performed a hypothesis test using a 5% level of significance. Using the known distribution of the test statistic, she determined a p-value of 0.0082. Now here, our alpha is equal to 0.05, and our p-value is actually equal to 0.0082. Now what does that mean? That means that the probability of observing such a value by chance is actually less than 0.05, which means it is statistically significant. So when the p-value is less than the alpha, that is when you reject the null hypothesis, you see? And then when the p-value is greater than the alpha, that is actually not getting it, okay? Like, what's the p-value again? And like, when do we reject it? No, okay? You're obviously not getting it. Okay, let's just find a way for you to get it, okay? I got it. Ha ha ha.
Talking away. You don't know what I'm saying, I'll say it again. P-value, the probability of obtaining the observed results if the null hypothesis were true. Hypothesis testing. If the p-value's low, and the null has got to go. If the p-value's high, then the null is all right. So needless to say, if the p-value is less than the alpha, usually alpha is 0.05, you reject the null hypothesis. Say it after me. It is statistically significant. Hypothesis testing. If the p-value's low, then we reject HO. If the p-value's high, then the null is all right.
So keep in mind that statistical significance does not always equal biological significance. Okay? It only tells you that you can be confident that there is a difference. So you see, if you want to find out if your observed results are not only statistically significant, but also important, you need to find the effect size. The effect size we will cover later on, but for now, adios.
So what did we learn from watching this video? We learned that in order to plan a statistical hypothesis test, you must first state the hypotheses. This involves stating the null hypothesis, in which our parameter is equal to the hypothesized value. The alternative hypotheses, or our parameter in which we consider plausible when we reject the null. We must also specify the statistical model. The analysis plan describes how to use sample data to evaluate the null hypothesis. The evaluation often focuses on a single test statistic. This step also includes verifying that the assumptions and conditions are met. We also learned how to analyze the sample data. Find the value of the test statistic, i.e. mean score, proportion, t-statistic, z-score, etc., described in the analysis plan to get the calculated p-value. And last but not least, we learned how to interpret the results. Comparing the p-value to the significance level, and interpreting the results obtained from the data. Now,
Try this.
Team Mew, the science crew. Team Mew, the science crew. Mew, 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 Mew. Team Mew, the science crew.
Bio 360.
Team Mew, the science crew. Mew, 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 Mew. Mew, 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 Mew. Team Mew, the science crew. Here's the crew.
As we learned in the last video, we have our p-value, which is the estimated probability of rejecting the null hypothesis. We also have our alpha, which refers to the likelihood that the population parameters lies outside of the confidence interval. We also learned about the statistically significant, which is when it's very unlikely to have a null hypothesis occurring. Today, we're going to learn about the null hypothesis, the alternative hypothesis, which contains of one or two-sided tests. For our null hypothesis, which is there is no significant difference between the specified populations. As for our alternative hypothesis, which is a statement of what a statistical hypothesis test is set up to establish. Now, the alternative hypothesis contains of one or two-sided tests. The one-sided hypothesis claims that a parameter is either larger or smaller than a given value by the null hypothesis. Whereas a two-sided hypothesis claims that a parameter is simply not equal to a given value by the null hypothesis. Now to the news. Thanks, Joseph. Now to the news. How's it going today, guys? As you guys can see that we're going to have a lot of snow for the next few days in all of Ontario's cities, which means that there is no schools in the next few days. Yay! That's in all of Toronto, Kingston, and Ottawa. Oops, that's actually the fake news. The actual news is we're going to have a lot of clearing up in the next few days in the cities that I mentioned before, which means unfortunately there's going to be school in the next few days. Now, in the best example, I had two parts. The first part is H0, which is the null hypothesis. In this case, there's no school due to inclement weather. But that is the fake news, which is usually rejected. The actual news is HA, or alternative hypothesis, mu is not equal to inclement weather. Now, in this example, I'm looking at two-sided tests, which means I don't need really to know if it's lower or higher. I just need to know that it's different. Now, if I want to look at things at either side of the test, my H0 will be staying the same as there is no school due to inclement weather. But in this part, my alternative hypothesis will be different. I'll be looking at either mu is greater than sunny or mu is less than snow. Now, to look at things better, I do have my normal distribution curve over here. If I want to look at things greater than sunny, my mu will be over here. If I want to reject the null hypothesis, my p-value will be something over here. But if I'm looking at things less than snow, my mu will be over here, and if I want to reject the null hypothesis, my p-value has to be somewhere over here. I hope you understand it very quickly and very easily. Now, we'll go back to you, Eve.
Thanks, Joseph. But keep in mind that the life is not always perfect, okay? There are always errors, even for the hypothesis tests, okay? Now, let's go to Dayana. Tell us more about the errors.
Thanks, Eve. Now we're going to talk about type 1 errors and type 2 errors, but there are a few things we must first take into consideration. The first one, power. Power that has a formula of 1 minus beta, and beta, which is the symbol for type 2 error. Now, let's define power. Power is the probability that the researcher will make a correct decision to reject the null hypothesis when it's false. The more power a study has, the less risk for type 2 errors to occur. The less power the study has, the higher the risk for type 2 error to occur. Other factors like effect size and significance level also influence power. Usually, we want power to be greater than 0.8, which means that we have at least an 80% chance or greater of finding the difference in statistical significance when there is one. With this value, we then calculate the sample size needed for a study, significance level. It just indicates that the researcher can be confident a difference exists. To determine how meaningful the difference is, the effect size needs to be calculated, and alpha of 0.05 is usually used. Effect size is our standardized measure of how large the influence of one variable affects another variable. The effect size is used as a part of power analysis in order to determine how large of a sample is needed to achieve the power that is greater than or equal to 0.8. There are different ways to calculate the effect size, one of which is to measure the standard deviation. Keep in mind, these are just guidelines. Effect size should be interpreted within the context of the research. Type 1 and 2 errors are inversely related. When you decrease one, you are technically increasing the other. Keep in mind that a type 1 error is considered more serious and as a result more important to avoid than type 2 error, of course. Now, let's talk about real examples. Okay. First of all, let's actually fill up the table. Now, let's continue. Let's say we assume H0 to be true in reality. If we calculate H0 to be rejected, we get what's called a type 1 error, also known as the false positive. Now, we're going to talk about type 1 errors. What are they? They occur when the researcher rejects the null hypothesis when it's true. The probability of committing this type of 1 errors is called significance level, which is also called alpha. In this case, the false positive is as seen in the following scheme. Hey, how you doing?
Oh god, I think I'm pregnant.
No, you are not. If we still assume H0 to be true and we calculate H0 to be retained, we get the ideal outcome, which is also the most plausible outcome. In this case, the ideal outcome is as seen in the following skit. Hey, how are you doing?
I'm not pregnant.
Of course you're not. Now, let's say we assume H0 to be false in reality. If we calculate H0 to be rejected, we get the ideal outcome. In this case, the ideal outcome is as seen in the following skit.
Oh, okay.
I'm pregnant.
Congratulations!
Thank you! If we still assume H0 to be false and we calculate H0 to be retained, we get what's called a type 2 error, also known as the false negative. Now guys, we're going to talk about type 2 errors. What are these errors? These errors is when the researcher fails to reject the null when it's false. The probability of committing these type 2 errors is also called beta, and the probability of not committing these type 2 errors is called power of the test. In this case, the false negative is as seen in the following skit.
What's the matter?
I'm pregnant.
No, you're not.
Where the girl is not pregnant. Alright guys, hopefully this was very helpful. See you in the next episode of Teen Mew, the Science Group. Bye bye.
So, what did we learn from watching this video? First, we discussed the one-sided alternative hypothesis. The alternative hypothesis can be either one-sided or two-sided. It is one-sided when it focuses on deviations from the null hypothesis value in only one direction. We also discussed the two-sided alternative hypothesis. It is two-sided when it is equally interested in deviations on either side of the null hypothesis value. It is important, however, that we do not jump into conclusions. The type of error that is more serious depends on the situation. We discussed Type 1 errors. A Type 1 error can occur when rejecting the null hypothesis if that hypothesis is true. The probability of this is alpha. Also, to decrease your chance of committing a Type 1 error, simply make your alpha value more stringent. We also discussed Type 2 errors. A Type 2 error can occur when failing to reject the null hypothesis when it is in fact false. The probability of this is beta. Not one number, but a function of the alternatives of the null hypothesis. Also, chances of committing a Type 2 error are related to your analysis of statistical power. Finally, we have effect size length. A larger effect is easier to see and results in a larger power, whereas smaller effects are naturally more difficult to detect, and we usually result in a Type 2 error and thus lower power. Now,
Try this.